Hello, everybody. This is the first unit of our first lesson of our last unit of the course. So it's unit 5 on statistics, and it's going to be chapter 7 and 8. It's one variable data, analyzing data, and the last chapter is on probability. So we're getting near the end here. So let's just get started with this. So with one variable data, or statistics, and you're analyzing data, right? You've heard it called. We're looking at one piece of information from a person or a place or something. So each piece of one variable data, right? Just either you're going to have like a number or a word. So numbers could be, the height of something, or the temperature or something, or mass, or the income, or whatever, some number value. Or it could just be an answer like your favorite team, or of a certain sport, or your favorite color, or whatever. Okay, so we categorize those. Those are called numerical data, right? When you have numbers. So if you have numbers, we're talking about numerical data. And we're talking about just a word or a grouping. We're talking about categorical data. Okay, that's the first thing to distinguish. With numerical data, so of those two types, right? Numerical data first. If you have continuous, so there's two types. Okay, so let's call it type 1 or whatever, right? So of numerical data, we got type 1. We have continuous data, and so it would have decimals. So when you're measuring things that have decimals, and there's some error measurement involved, and so quite often you might be graphing those as either scatter plots or line graphs. So a line graph is nice if you want to see like how it changes from moment to moment, like a stock market or something like that. In a situation where you might have a relationship, you saw in the previous units, that you might want to draw this one as like a pattern, right? If there's a relationship, right? There might be like an equation, y equals or something like that. Then that would be like a line of best fit, or a curve of best fit would represent the relationship. Or like I said, if it's just a straight line graph where you're just connecting dot to dot, so dot to dot shows daily changes or yearly changes or whatever, right? Shows changes as they happen. So dot to dot, let's just say, because day to day or year to year or whatever, dot to dot works. So they both have their value in different situations. Okay, so definitely stock market, I definitely see that one as this one here on the right, as applicable to that. And this value of a vehicle and so on, it might be more of a pattern relationship, right? So having a line of best fit for that might be better. So with numerical data, continuing on, we have discrete. We said like number of goals scored or number of children and so on. And then moving on to categorical data, we'd have categories, like we said before, colors of a car. Things like that. Okay, so types of graphs we're using for categorical and numerical often are these ones here, where you have bar graphs, circle graphs, or pie graphs, pictographs. Okay, and we'll be looking at each of these and looking at how to make each of these as we go through the course. Hope I don't get copyright infringed for this. This is not my video, it's from YouTube, but just it's meant as a little funny joke about this. Let's see if it plays here for us. Hopefully you can hear that. There we go. Why is it so dark? I don't know if you're a How I Met Your Mother fan or not, but it's a pretty funny show. And I was watching a lot at the time when I saw that episode as a math teacher. I was like, oh, I'm going to have to get a copy of that for my class to watch. And of course, now with YouTube, it's easy to do that. So a pie chart about his favorite bars, and a bar graph about his favorite pies. That's pretty funny. So here we go with a pie chart or a circle chart. And so this question is just about reading from them, right? And so it shows it says 15,600 students. In a guided example, we're asked this question: if you had $1,000 to give to a charity, which would you choose? And here's the results. Okay, so which choice is the most popular? I think it's pretty easy to look at this graph and see like this is the biggest piece, right? So that's the most popular. And then it said how many students chose to donate to wildlife and animals. Obviously here you can see that it's 17%. So you could say like 17% donated, or you could actually do 17%, right? So 0.17 times the 15,600 and get the actual number, right? The actual number of students that donated to that. It would be just a calculation to go along with that question. It says a circle graph shows each category as a percent of the complete data set. It's quite often. Why is it a good idea? Well, it just obviously just gives a number value associated with the fraction of a circle that's there. What type of data would not fit in a circle graph? Like continuous data, things like that. It's more for categorical and like colors of your car, colors of car you like, things like that, right? So if you have like decimal measurements and numbers, it doesn't fit as well, and just doesn't make sense to show them that way. So another type is histograms, which it's pretty easy to get them confused with bar graphs because they look really similar, but there are some differences. And histograms are specifically for when you have continuous or numerical data, but especially continuous. And so you divide it up into intervals. And so your interval from 0 to 20 and then 20 to 40 and so on for annual income, for example, there's no spaces between those values. There isn't any, like, no one makes 20 to 40, so it leaves it blank or something. So there's no spaces between them. Whereas if you look back at bar graphs, there's usually spaces shown between them because you have your favorite, I don't know if this is colors of cars or something, people like red cars, green cars. It's probably not colors of cars because there's not that many green cars on the road, but it makes sense to space them out because there's no connection between the columns, no connection between the bars, whereas here there is, right? It's literally, they're side by side, right? So another just summary kind of a question here. Just label the type of each graph. So press pause, give it a try, whatever, and obviously just check and see how you did. So if we're looking at obvious ones, it'd be a line graph here, and a pictograph. I didn't talk as much about before, so I should emphasize that now. If you have pictures to do with things, I did it up here, right? We had pictographs. I just didn't mention it as much. But pictographs often have like a picture that's associated with what you're talking about. So, so that's that. And then pie graph, circle graph, obviously here. And then save the confusing two for last here. One's a bar graph and one's a histogram, right? The histogram is one that doesn't have any spaces between things, whereas the bar graph is like separate categories. So they have a bit of a separation between them. So this graph here, what type is it? So obviously it's pictorial, right? Just like this kind here, where we're looking at a pictograph. So this is a pictograph type. And then, where might you see this kind of a thing, right? I think you'd see it in someone who's trying to convey information to the general public. You might see it in magazines, websites, or some kind of video that's trying to educate you about something and get you to make changes in your life to better the world, or whatever the case may be, right? So magazines, if they still exist, websites, right? Persuasive videos, etc. And why? Well, they're very easy to. They're nice to look at, right? They're nice looking and they're easy to understand. Interpret or understand or whatever. They're high impact. They're visual. They're pleasing. It gets people's attention, right? What do we have here? So this example has bar graphs and pictographs of the same data, and so if you're just asked to draw the bar graph, obviously we're gonna do a draw bar graph in a second, but basically, how would this work, right? So we'd have to divide the horizontal scale into sections, right? So a section for January, a section for February, and so on. and it's listed as a bar graph, separate months. I almost see an argument for them to be side by side here because there's no space between January and February, for example. But if it's done as a bar graph, there will be spaces. So a bar graph, there's going to be spaces. And then a picture graph, obviously, it's just pictures, right? So at the end of having drawn these, like you divide up the horizontal scale into a bunch of categories or sections, and then your vertical scale, you'd have to have it go from like your largest number to your smallest number. And so what they're not showing here would be if you had a bunch of data points and you'd have to count up how many there are, a certain value and so on. So actually that comes up in a later example. I shouldn't say that really. So they have just the average value overall, right? So this, as you go, you just number them. And so if you look at the highest and lowest values, mind you, I don't necessarily know if I have the highest and lowest values because I'm missing some of the numbers. But you'd have to have your scale along the vertical here be divided up into enough sort of pieces, right? And so basically you do like your max minus your min and then divide by the number of spaces. And that would help you figure out what you want to count by. So counting by tens, brought us all the way to the top in this case, right? So this number might have been 9.2, in which case we rounded up to 10. Counting by 10 brought us to the maximum number. Okay, so when we're reading things from this, part B says how much rain falls in the summer months, July and August. So obviously you just look at July and August and look at the amount of rainfall. I have some blacked out here so we can look at how they match, right? So the January number, you'd be reading from the graph and seeing like, oh, well, we're going to be more than 40, less than 50, right? So you might approximate, right? So 47 is what they said. If we were drawing the February graph, we'd want it to be at 46. And so it's going to be just a hair smaller than this one, I guess, because that one's supposed to be 47, right? So it's going to be just a hair smaller than that. So you see like, okay, there we are as expected, right? Just a bit smaller. What else? July. So July listed here, you can tell on the July month, we're above 70, 72, 73, something like that. That's good. And so on as we go. August. What would August look like? It's 82, right? For August, it's 82. And so you'd go across at the 82 mark somewhere in this height around there, right? Roughly speaking. That's not bad, right? So let's get that out of the way for future use. But this would be a little harder to interpret, even though it looks nice. It's flowers, I guess, growing because of the rain or whatever. But then you'd have to interpret like what each flower represents, I guess, right? So if you look at it, this is supposed to be 47. And so this is basically each flower represents 10, I guess. So you got 10, 20, 30, 40. And then this is like 0.7 of a flower, I guess. Not my favorite. Right? The pictographs are nice for magazines and everything else, but as a math person, just trying to get numbers, it actually makes it harder, even though it's better visual impact and maybe get more the point across to more viewers. As a pure math person looking at it, I'd rather just be able to get the numbers. As says, add the average rainfall for July and August. Oh, that's just the answer there, I guess, right? So let's give you about 154, so you add them together and divide by 2 or whatever. Anyways, just working with the graphs, obviously just use them, right? So the next step is to be able to say, okay, well, let's make one, right? Let's organize the data into intervals and create a bar graph and so on. Okay, so for this, the first step is to create a tally chart, figure out how many red we have and how many, whatever. So if we look at it, each time we cross off one of the reds, you just make a tick mark, right? So there's a red, there's another red, there's other reds on there. I don't think there is, but if we find another one later on, we can just add a tick mark. There's a gray and a gray, so there's 2 there. There's another gray and a gray, so 2 more. There's another gray here, so tick mark that across, so that's a group of 5. There's another gray. I don't know if you've been in parking lots in Ontario. Lots of gray cars. Probably more than that percentage, to be honest, but keep going here. Blue. 1 blue. Any other blues in there? Brown. Any brown cars on the road. We got 2, 3, 4, right? Another one, 5. Just basically as you go, putting tick marks to keep track. There's 5 of those. And then white. 1, 2, 3, 4, and so on. Go. So yeah, I think that's it. So we can tell we have a frequency of 2 and adds up that 5 and 1 adds up to 6, 1, 5, and 4. We have as our values. So the gray being the most common, which I think you'll notice if next time you're in a parking lot. So here we go. We're looking at dividing this. The horizontal would need to be divided up into, we can just talk about how this would be done, right? But the horizontal needs to be divided up into 1, 2, 3, 4, 5 groups. So when we're dividing this into 5 groups, you might count how many spaces there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20. So there's 20 spaces. So we got 20 spaces divided into 5 groups. Gives you 4, and so that's how the 4 was chosen. And then if this is a bar graph, you might just sort of choose like a portion of that to be the section, right? So you could do this as like a red bar and a gray bar and so on for better visual impact, which it could do, but or it could just be, each one of them could just be the same boring white rectangles, right? So make rectangles like that out of things, but let's just for now make the white, and then I can change the colors afterwards maybe. So for the red, it's supposed to be only 2, right? Oh, vertical scale. How was the vertical scale chosen? We need to have 6 fit on our scale, right? So if we take 6 and divide it by the number of spaces, so 3, I think it was 20 again. So 6 divided by 20. See how this scale was chosen, right? So it's 0.3, right? So depending on how you want to do this, I probably would, if I was doing this right now with you this time around, I'd probably round that up to 0.5. And if I rounded that to 0.5, then really I'd be counting by ones. I'd have 1, 2, like 1 every 2 spaces, I should say. That'd be 1, 2, 3, 4, 5, 6. And I just wouldn't use as much of the graph. So round up to that, or in this case, they rounded to like 0.333, rounded to a third. And that just makes it so you use more of the graph. So I'll stick with that one, but I don't know if that would be the most common choice or not. That's certainly doable. Just trying to get rid of my green pieces here. All right. So that's what this was dividing into thirds, and so every 3 spaces and so on. So we wanted for red, we wanted 2, and so 2 is easy to find on the scale, nice and easy. So there we go. And let's see if this lets me resize this easily here. There we go. So there's the bar for the 2. There we go. And then, close enough, I guess, right? 6 for red. And so let's just make another one of these things. Make a bunch of them for as we go through the question. So we're on 6 of the gray. So we're going to go up to the 6 mark. And just that. But just use a ruler and draw lines. Like it doesn't have to be digitally done. It's the 6, and then blue, and so on. So blue was only 1. So 1. Like that. Oh, it always changes slightly on me. There we go. Brown and white. The blue should be in the middle there. Brown, 5 and 4. So a 5, 4. Right? So that one has to be around there. Change a little on me each time I do this, but there we go. second try matches it nice. So if you, like I said, if you're submitting something, it might be not a bad idea to make this a little easier to understand here. And so the fill color, make it be the red, and make it be the gray, and the blue, and so on. Just pencil crayons, really, if that's how you're doing things, it's fine. Brown, I guess, more of a beige, but get the idea. And white's automatically good to go. Okay, so choosing scales just like you do for graphs normally, but leaving a space and sort of thinking it out a little bit. All right, so that's your introduction to analyzing data and making graphs and so on. So this one has a, make a bar graph. So you have 1, 2, 3, 4, 5 groups again. So go ahead and do your work, divide up your spaces, and their biggest value is 54. So 54 divided by how many spaces? Choose something to count by to get a scale that matches nice. Second question is easier. You're just identifying if it's numerical or categorical and continuous or discrete. And this one is one where you have to do a tally chart and then get the numbers and then make the bar graph. Okay, so that should be pretty doable based on what we did. So there we go. All right, so if you have any questions, let me know. And all for now.